like API development, on and so forth. So there are some reasons. One of the reasons, I hope you can agree with me, that Python is one of the easiest languages maybe you can start with. Then now you can even proceed to other ones. So the reason why it's easy is because its syntax seems like English-like, and its setup is not that complicated. So long as you have a Jupyter notebook or a Google Colab, then basically you can actually start practicing this programming language. And because this course was mainly focused on data science and data analytics, we will not proceed with more advanced topics in Python, like data structures, algorithms. So that is actually now a completely new course for you. So the main focus for the Python we were doing was mainly to do with data science and data analytics. So far, so good. I want to go through what we've been learning from day one up to now, where I feel like now we're even exploring some more intermediate or advanced topics, okay? So we started with variables. As I'm always reminding you about this building block, it's very important. So if you really want to do any other programming language, I think you can still follow the same outline we did, okay? You basically start with variables. So just to remind you, we say that a variable is a name that we use to store data in your program. That is a variable. So there's something to remember about variable is how do you name them? And as you name these variables, please always keep in mind about the guidelines that we mentioned, okay? So that is important. I always feel like that is the first component that you need to understand in any other programming language out there apart from Python. So from there, we talked about data types. So if you're learning data types, then basically you're trying to understand some of the different types of data you can have in your program. So you can have numbers, you can have text, you can have collections, you can have maps, okay? So in Python, we said we have either integers. For numbers, we said we have the integers, the floats, the complex. For text, we said we have strings. For collection, we said we now have the list, tuples, range, sets. We also have dictionaries and booleans. So those are some of the various types of data that you can work with in your programming day to day. So what you need to keep in mind about these data types is that each and every data type have their own operations, okay? Have their own operation. So operations that you can do to a string should be very different from operations that you're doing to a number. And basically, those are also different from operations that you are doing to a list or a dictionary or a tuple or a set. So always keep in mind that as much as now you're learning programming, you need to understand the various types of data that that programming language supports. If you're learning a language like JavaScript today, we even have more that are not here. Okay, there's even a data type in JavaScript called undefined, okay, or symbols. So basically, it's always important that if you're learning a programming language, you need to understand the various types of data that that programming language can support. And that is important, and that is what we did in Python. Now from there, if you feel like now you're able to deal with different types of data, we went to the third building block where we talked about the conditional statements. So this is very vital because it's actually the foundation of decision making. So as much as you're doing programming, there is at some point, you might want to make a decision, okay? And we saw that these decisions that we make are based on conditions that we put in place. And we said that these conditions, they can either be true or false. And that is what we call a Boolean logic. So in programming, we normally say that we can execute some specific blocks of code when a condition evaluates to Boolean true or to Boolean false. So we talked about the if conditions, we talked about the if-else condition, we talked about the else-if condition, and I think if you even go through my notes, we also have the nested conditions, and they're also very, very important in programming. So that is also very, very important. So you cannot do programming without making a decision. So that is important. Then from there, we went to the fourth building block, and we talked about the looping statements. And we saw that looping statements now allows us to repeat some sections of our program based on some condition. Okay, so even give you a good example. You are trying to allow a user to log into a system, but now the user provides the wrong password or the wrong PIN. You can repeat that section for the second trial and repeat it again for the third trial. And in case the user is actually having 3 failed attempts, then definitely you can block the system. So in that scenario, looping statements are very important when some section of the programs have to be repeated. And the repetition, we said that it is basically based on some conditions that are there. So in Python, please always remember, we have mainly 2 types of loops, and that was the while loop and the for loop. They are very important. We say that while loop are used when you're not sure about how many repetitions you want to do. So you can actually work with a while loop. And on the other hand, a for loop, you can basically use it when you want to iterate iterate through sequence data types. So we mentioned about list. When you want to get information from a list, from a tuple, from a set, from a dictionary, from a range, then that is actually where you can work with the for loop better. So in our previous class, which was on Thursday, we talked about functions, and we saw it's very important that because functions are reusable blocks of codes, that we saw that they are actually designed to perform specific tasks in our program. So it's always important to remember that we have majorly, we actually have different types of function. The first one that you meet are the built-in functions. And we saw that, if I might open that one, because it was our last class, built-in functions. And we saw that these are mainly functions that you don't need definition. They're already existing in your program, and they're actually doing specific tasks in your code. A good example of this function is the print function. We saw that this is a function that specifically displays information back to the user. Okay, we also have the length function, which is actually returns the number of items in a sequence data type, the sum, the type, the range, the input function, and so on and so forth. So those are what we call the built-in function. And we saw that you can actually not do any programming without them. Let's say I want to display data, I need to call a print function. Something to remember about function that I always want you to remember in any other programming language is that functions, normally they have to start with the lowercase. I hope you see that one. They have to start with the lowercase. Please always remember that one. And also, they have a bracket. So this is what this actually defines that this is a function. All the functions that you'll meet, I think in almost any other programming language out there, they normally have this kind of a bracket, and we normally call it a parenthesis, okay? And they're actually doing specific tasks in your programs. Now, moving further, we also did the user-defined function. And we said that these are functions that are created by programmers or data scientists to perform specific tasks. So therefore, if you want to work with a user-defined function, then you first have to define them, And we said in Python, we normally work with a define keyword, and then you call them anytime now you want to perform that operation. So basically, that is what we mentioned about user-defined function. So please remember, we talked about parameters, we talked about arguments. We said that parameters are the variables that accept values when a function is called. Arguments are values that you pass when calling a function. Always remind about that one. So in more advanced programming, that I think is already there, you might meet other functions that we call them the lambda functions. And we saw that we never did them, but just to say that a lambda function, it's a function that it doesn't have a name. Let me just say it is anonymous, okay? And you can realize that they are often used for short operations where a full function definition is actually unnecessary. You don't want to define a function and then call it for a short operation. So in that kind of an operation, you might work with a lambda function. I don't want to do them at this point because it might confuse us with the user-defined function. But now when the right time arrives, we're going to talk about them as well. And then most importantly, for more advanced operation, you're going to meet now the recursive functions. They are very important. And if you read more about them, you're going to see that a recursive function is basically a function that calls itself, okay, for some problems of a task. And one area that I'm sure you're going to meet recursive functions is when you're doing your data structures and algorithms. So you're going to meet now this recursive function, and you're going to see how useful they are in some more complex operation like traversal. You want to generate factorial, you want to do Fibonacci series, and so on and so forth. So for now, especially now for data scientists, I just want you to remember the first two. Remember, we have the built-in functions, and we also have the user-defined function. So more to read is about the lambda functions and the recursive functions, okay? So that was very important. We saw that with function, you can actually now do more operations in data processing. You can use it in cybersecurity. You can work on automation. You can do machine learning and AI, and so many other ones, including game development, okay? Now today, I hope you're ready. Today, like I promised, we want to talk about modules, and then later we discuss object-oriented programming. So these are two, I can even call them advanced topics, but they will be very, very easy so long as you understood the first 5 building blocks. I hope now you understand what is a variable, what are the data types, can you create a conditional statement, can you work with a loop, and can you define a function? So now from there, I want us to go direct to functions. So you are going to realize that modules are still part of functions. Module is part of functions, okay? So the nodes are here. The nodes are here. So we want to define modules. You want to see their characteristics. You want to see how to work with them. How do you create them? How do you install them? I think I've done a repetition again. I should remove one. So that one. Okay, well, I'll check on that one. And then some of the summary. So we're going to talk about modules, very important. And later, I would hope now everyone should join. We now go even deeper and discuss the object-oriented programming. So let's start with modules. Let's go here. Let's start with modules. So I want to go right here, modules. So as usual, I want us to set up the environment as we've been doing that one. So the first thing we do, we need to get the nodes. So these nodes will help us understand modules theoretically. Then from there, I want you to open up the notebook think it should be the last slide. So I want you to open it on a new tab. Just open it on a new tab. Control copy. Then basically, I want you to paste it right here, modules. Now from there, as usual, I also want you to create a separate notebook so that you can now start practicing on Python modules. So in case someone is experiencing some issues with the portal, you're not able to access these materials, as usual, you can also find the guide here. So I've shared with you the Colab notebook here. I hope you can see it's already here. And now I also want you to open up. So please, I'm always encouraging you to practice. So this is the best way you can learn. So programming will be even easier when you try to practice, not just watching it. It's not easy when you just watch it. So it's best when you practice it. So for that reason, we will now need to open a completely new notebook here so that now we can start practicing on Python modules. So that is actually how you're going to learn this program. We have our notes, we have the guide, and we do our practices. So like we've been doing it in other previous classes, you need to give it a name. So I'm doing the same. So let's call this one Python modules. Python modules class practice. And then let's say this is our morning session. Yeah. So now I hope you're ready. I hope you have the notes. We want to start from here. We move to the practices that we want to do. See, we have a lot of things. No, they are not that much. Just want to highlight them. And then we try out some practices right here. So I hope you're ready. I hope you're ready. Let me give you a minute. For anyone who is not there with me, you do your setup. Then we can start together by now discussing what are Python modules. So make sure you have the notes so that we go together. You have the notes. Make sure you have I can call it the guide notebook. So the notebook that will guide us on our class practices. So make sure you have this one and now this one. So now we can move together seamlessly. Okay, so let's start. Let's start. So my hope is that now you understand what is a function. I hope that is my hope. You understand how to define a function and how to call a function. And you know what is a parameter and what is an argument. Up to there, you're good. So now we can say that in terms of definition, a Python module, it's a file. I want us to remember this one always. So what is a file? A file must always have an extension. So for example, this is a file. Its extension is .ipynb. This is a file. You can have a music file because it has an extension .mp3. You can have a video file because a video file will have an extension .mp4. You can have a document file. It will have an extension docs. We can have a PowerPoint file where we have an extension PPT. So, like we've been saying now, a module is a file. And to be specific, it's a file that ends with .py. It's a Python file. So a module is a file that contains Python codes. So you're going to see that a module contains functions, classes, and variables that can be reused across multiple programs. So let me be specific. You have a file that contains functions, classes, variables that you can use in other different files in your program. So that is what we call a module. And later we're going to see that if you understand clearly what are modules, then we are able to improve our code organization. That is what is the vital part. we can actually now have what we call code reusability and then code maintainability. So let me repeat, a module is a Python file that contains functions. Because now we're doing OP today, we're going to see classes, variables that can be reused in other multiple programs. So why should we have modules? So these are the key characteristics. If you're dealing with a module, then you can actually have code reusability because you are able to reuse code across different programs, reducing some code redundancies. We're going to see that one. We'll talk about encapsulation, whereby, so this is very vital, whereby we can group related function into a single file. Okay? Then we can now make our code more modular. Like, let's say I'm doing a project to do with web development. I want to build a web application. So I can have file that contains, and let's say, security functions like encryption, decryption, so on and so forth. I can have another file that contains database operation, like when I want to add information to a database, when I want to remove information from a database. I can even have another file that contains the UI, the front end, the user interface. So now I'm making my code even more modular. So with modules, you can now have related functions into a single file. We're going to talk about namespace management later. We can now import them, and then we can even now use standard or third-party library. And that is the beauty why we are learning modules today. So now moving further, so that now we can clearly understand modules, we have different types of modules in our program. So I want you to imagine we have built-in modules. So in your program, we already have some built-in files, okay? So built-in Python includes several built-in modules such as, so we have files whenever you want to do your mathematical operation. So there is a file called math.py that when you import, you can actually start doing mathematics operation. For someone doing cybersecurity and you want to interact with your operating system, there is a file called OS. So OS is a module. So it's actually a file that you can import whenever you want to interact with the operating system. So it's a very vital file for those people who are doing cybersecurity and ethical hacking. Because if let's say I'm able to access your system is built on an operating system. So for me to start working with that operating system, I need to work with the OS module. We have the system module, and this is actually the system-specific parameters and function, okay? We have the date and time, we have the random, and so on and so forth. So these are what we call the built-in modules. So what you're going to realize about built-in modules is that you don't need to create those files. Those files are already available for you. So what you just do is just import them. Apart from the built-in modules, we also have the user-defined modules. So user-defined modules are the modules that are created by the programmer to structure and reuse their code. So we are going to see that a user-defined module is simply a .py file. So it's a Python file containing function, classes, and variables that this programmer wants to reuse in their code. So these are what we call the user-defined modules. And now the beauty is here. I want us to see now. Apart from the user-defined module, we have what we call the third-party modules. So basically what I normally say is that third-party modules are what you get from the internet. So these are external modules developed by the Python community and installed using the package managers like pip. So today we're going to meet the word pip because you're going to use it to install these third third-party modules. So an example of a third-party module is a module like NumPy. This is what you want to start learning tomorrow when you're now introducing data science. With Python, we are going to learn about NumPy because NumPy will be very useful when you're doing numerical computations. Later, we're also going to talk about pandas. So this pandas is a third-party module. So it's a module that was developed by the Python community whenever you want to do your data analysis, okay? We have more even, we talk about requests. Anytime you want to talk about the HTTP. So we are going to do this one, especially for those people who are doing web scraping, because a request module allows you to communicate with the internet using the hypertext transfer protocol layer. So this is a very important module, especially for those who are doing APIs, if you're doing web scraping. So long as you want to connect to the internet from your Python file, then definitely you'll require the request library or the module. We have matplotlib whenever you want to do data visualization. So I want us to see the connection between Python that you're learning and the operations that you want to do. For this specific class, we want to do data science. So basically what you're going to learn from here are the modules. Specifically, we'll be learning the third-party modules that are responsible for data science or data analytics. And the first one that I think we're going to start with tomorrow is the NumPy, numerical computing module. We're going to talk about pandas, we're going to talk about scikit-learn, we're going to talk about matplotlib, because as you can see, this is what we want. We want those modules that can manipulate data and extract insights from data. So now, in this lesson, we want to see how do you work with modules. So the first way is you can basically import them, or you can create them, okay? Or you can now install them. So the most important one here that I want us to keep in mind, I will not talk about importing a module. That is important. I will not talk about creating a module, but I will focus on installing a third-party module. And we're going to use keywords like pip. So pip is actually a keyword that we use at any time you want to install a third-party module in your project. I'm sure because maybe you'll be doing some pandas, we'll be using pip to install NumPy or pandas later. So why should we learn modules? So where do we use them? Whenever you want to reorganize our code and reuse our code. Those people are interested to do data analysis and machine learning. If you want to use Python for your web development projects, there are even third-party modules like Flask and Django that are actually tailored to manage web applications. So those people want to do software engineering using Python, then if you just proceed here, you just need to understand either how do you work with Flask or how do you work with Django. So those people want to do system automation or scripting. So we have modules like operating system and SHUtil that will help in automating file operation. So if you want to do cyber security using Python, there are the modules like Scrappy and Socket that are used for network security analysis. So this was I think was a repetition that I would avoid. So now let's go to the code. We basically try to practice on modules so that now at the end of the day, we're able to understand them and work with them in our programs. That is now if there is no question up to there. So let's practice on them. Let's practice on them. Let's practice on them. So we're being told that a module is a file that contains sets of code or sets of functions that can be included in an application. So let's say you want to do data analysis. You will definitely need a module like pandas, because pandas contains sets of codes or sets of functions that can be used in a data analytics application, okay? So what you're going to see is that a module could be a file containing just a single variable, a function, or a very big code base. So there is even a module that is interested on game development, okay? So here, like I mentioned, I will not focus much on how do you create a module, because if you want to create a module, so we are being told here that to create a module, we just write our codes in a Python script, and then we save it as .py file, and then create another file so that now we can start importing those files here. So just to demonstrate this one, because you're not going to do it here, is that I have a file called mymodule.py. I hope you can see that one. I have a file called mymodule.py. This file, I have actually defined a function that can return my full name. I hope you can see here. Now, the beauty is that I can definitely use this function in a different file and therefore refer to this file as my module. So there is a module called my module that contains a function here. So now how do you use this function on a separate file? So what I'm trying to demonstrate here is that we have two files here. There is a file called mymodule.py that we have a function to generate our full names. So we already did that function. And now this function can be imported on a different file. So to import the file, we will use the import keyword, and the name of the file only. So we can actually say that now I can say, I want to import my module. So I want us to see that right now we are inside the main.py file. So we can now say import my module. So from importing this module, now we are able to use this function on a separate file. So that is what I'm talking about. We have a file with a function or a variable or a class, and we can now use these functions on separate files here, okay? So I want us to go direct, so because of time, and we talk about built-in modules. Okay, let's talk about this one. So we can say that, like other programming language, we can also import modules by importing the file function using the keyword import. So let's now let's import the common modules that we use most of the time. So some of these common modules are the built-in modules like the math, the datetime, the operating system, the system, random, statistics, collation, JSON, regular expression, and so on and so forth. So let's start with the OS module. So let's start with the OS module. So I want us to go to a class practice here. Let's go to a class practice here. I think we've talked much. Now we can say, today we are basically discussing modules in programming. So other people might even confuse you. They can even call them libraries. Other people call them libraries. Some other guys refer to them as not close, but we can also call them frameworks. Yeah, I think it's more or less the same in programming. So to define them in a short sentence, you can actually say that it is a Python file. So a module is basically a Python file. So how do you know that this is a Python file? It has to end with .py. That one is a Python file that contains functions or classes that can be used on another file, Let me just say on another file. So we need to learn about modules because they normally enhance what we call, they enhance. So our modules enhance what we call code reusability and code organization. Code organization. Code organization in your application. So you can actually work with modules anytime you want to organize your programs or reuse some programs that are already there. Like a good example, you want to do data analysis. You don't need to create your own functions for data analysis. That will take you a lot of years to do that one. So basically, you can import a module like pandas and start doing data analysis at that moment, okay? So we've seen that we have the built-in modules that I want to talk about. So I want to talk about the built-in modules. And most importantly, after this one, I will also talk about the third-party modules, okay? So the first built-in module we've seen is number one is, sorry, it should have been a comment. Number one, I also want to talk about, the OS modules. So the OS module. So the OS module is actually a module that contains functions you can interact with operating system. It's very commonly used, and you're going to meet it in so many applications. So for instance here, to use the OS modules, let's just import it here. I don't need to define it. Let me just import it here. Import OS. Okay, import the OS. So with the OS module, I can actually get some detailed function like, let's say I want to get the name of my operating system. Let's say I want to get the name of my operating system. Let me just run and see. But this is Colab. So I don't know. Sure, let's just, this could have worked when I'm working it locally. So I can even get the name of my operating system. So Colab works with this operating system called this one. So this is for Colab. And currently, we're actually getting the current working directory. I'm in actually a folder called content. And the list of directories that are there is config and sample data. You can see this one. So I hope you can see that with OS module, I can get the name of your operating system. Let's say I want to do an attack to your application. I need to know the name of your operating system. So for Google Colab, this is actually what we call the POSIX. This one is the operating system that runs Colab. The working directory that we are in is what we call the content. This is the folder that we are in. The list of directories that are there is something like config and sample data. So if anytime you're dealing with an OS module, then a folder will always be called a directory, okay? A directory. So it is normally represented as directory. So this is what we call a folder, okay? So this is what we call a folder. Now with the task I have here, I want to create a directory. So I want to create a directory here. It's like I want to create a folder. Create a directory or a folder. A folder. I hope it create. Let me just see. Should have created it here. I hope you've seen the folder has been created. So there is a folder called this one here. This is here. This one here. So normally Windows work with the graphical user interface, but you want to create this one in a command line. We can actually say that in the OS module that have been imported, I can make a directory. This is what we call make a directory here. Okay. This is very important. especially now for those people who want to maybe do cyber security using Python. So I've created a folder. There are so many operations there. I hope we can see. We can even change the directory. So right now, the directory we are in, let me show you this one. Very interesting to see. But I hope it will not interfere. I think it might interfere with our cooler, but let's say you wanted to move from the content directory to another folder, then you can do that one with Python using change directory command. You can also get the current working directory. So get the current working directory, and then you can also remove the directory. I think I can try this one. I can also try this one. If I want to remove the directory, I can pass the name of the directory here. That one, we'll see whether that will work. File exists, so I think I cannot create when it's already existing. It's already there, so I can just remove it. Now it's already there, then it's gone. I hope you can see. So these are some of the codes that most people in cyber security operations use. Anytime they want to delete information, they want to copy data or anything like that, they are actually very good on the OS module. And if you want to do that, you can actually practice more on the OS modules that we have. Only that this is actually a cooler. If you actually in a normal computer, then you could have seen how powerful the OS module is in our application. So just to say, and the OS module is mainly used to interact with the host, host operating system. So you can create files, you can create folder, you can delete files, you can copy files, and so on and so forth. So that one is okay. You'll practice more. Just wanted to show you that we have the built-in modules like the OS module. I think we even have the system modules that provides functions and variables that are used to manipulate different parts of Python runtime environment. Okay, so a good example, there's a function like system.arg returns the list of command line arguments passed in a Python script. So these are, I think, it's more technical, and we can actually have system.exist, system.marksize, system.path. Anytime now we want to interact with the system operations. There's even statistical module. So statistical modules provides functions for mathematical, statistical, or numerical data. Okay. So if I copy this code here, just copy this code here. I think this is something we are going to learn in our statistical classes. For example, you can now say that from this module called statistics, I want to import all the functions that are there. So if you want to import all, then we work with this asterisk here. So this asterisk says that I'm importing all the functions that are hosted in the module statistics, and I want to use them in my project here. And now the situation I mean is that, let's say I have some data, like I have the list of ages. Okay. So if I want to do some statistical operation like the mean, the median, the mode, standard deviation, I can always work with the statistical module. And remember now we're even getting now our analysis. Let's say I wanted to get your mean marks or your mean score. I want to get the mean age. I want to get the standard deviation. I can always work with the statistical module. And this is what we are getting right here. So for those people, like I was saying, you are afraid of mathematics like me, and now you realize that we need to have mathematical skills in our data science project, then basically we can actually work with these modules like this one. Because if you are told to calculate the standard deviation here manually, then it will take you a lot of time and you'll have to follow some steps. But now with the statistical module, we can actually do that one in a very short period. Moving further, we even have the math module. So let me just copy this one. So the math module is actually focused on different mathematical operation and constants. So for example, here, if I import math, I can get math.pi. So this one talks about the variable. Let me try this one here. So if you want to get the pi, just say import math and then get the constant like pi. Then you're getting the pi is 3.1421415, that order. What about if I want to get the square root of 2? So I can just say I want to use math to get the square root of 2, getting this one. And if I want to use math to get the power of 2 to 3, it's like 2 to the power of 3, then I'm getting 8. I can also do the floor division. So math.floor. So we say that floor is when now you want to round off this value to an integer. So if you round off this value to an integer, then you get 9. Cell is when you want to round off this value to the highest integer. So this is to the lowest integer, we do floor. The highest integer, we do cells. If I want to do logarithms, so for example, I want to say math dot logarithm 10 of 100. So I'm getting 2. So I'm getting 2 here. So logarithm with base with 10 as the base. So basically, we are being told here that anytime you want to do mathematical operation, then you can actually work with the math module right here. Okay. So we can also use alternatively say, so we have 2 ways of doing that one. You can just say, I want to import math, or I can also say, I want to say, from math, I can now import a certain function like pi. So it's something you're going to see, and so on and so forth. So we also have the string modules. Just copy this one here, string module. Anytime you want modules to deal with characters, if I copy this one here, string module. So if I run this one, I want to get all the ASCII characters. I want to get all the ASCII characters. Then I'm getting all the alphabetical characters here. If I want to get all the digits that are represented in a computer, I can just say string.digits. I'm getting all the numbers. I can even get all the punctuations that are available in a string. So this is actually the string module. I hope you're also trying them out, so that now you're familiar with them in our application. So moving further, we also have the random module in such a way that anytime you want to work with random numbers, we can actually call the random modules. So let me just run this one here and use it here in our program here, that one. So what you can see with the random module is actually used whenever you want to generate a random number. For those people actually doing game development, this is actually very vital. So if you run this one, if you say random, it doesn't take any argument. It returns a random value between 0 and 1. It returns any random value between 0 and 1. So if I run this one again, it will get me a random number. Then, if I want to get an integer, because by default, random returns a float, I hope you can say. So if I want to get an integer, then I can work with a random integer. Random integer. So if I can say I want a random integer between 5 and 20. So it returns a random integer between 5 and 20. So if I run this one again, I get 19. I get 6. I get 19. So I'm getting any random integer between 5 and 20. And I think from here we can even build a simple game using the random integer. So, and so many other ones. So basically those are what we call modules, and they are basically used whenever you have a file that have functions you want to use in your application. So we have the built-in modules, and now tomorrow we'll be talking about the third-party modules, like now NumPy, Pandas, Matplotlib, scikit-learn, and so on and so forth. So any question up to there? The modules, I hope at least you have an idea of what is a module. Yeah, so let me check. Oh, yes, Dennis, you're getting an issue, so let me check it out. First, I don't know. Oh, so I think you are trying to build a game, so then you're getting an issue. So maybe you can rectify that game. I don't know, I'm not getting that code. Just a minute. Check on it very fast. What's happening? I think you're trying to build a guess game. I'm not wrong. So let's just rectify that one. And then we can now proceed. Yes, copy this one. Paste it right here. Let me say installation. Okay. So can you hear me? I think I was rectifying the code. I think now it's okay. It's a good project, Dennis. Was it Dennis? It was a good project that demonstrate how you can work with random. So it was a good project to demonstrate how we can work with random from, was it Dennis? Yes, Dennis. So you can also try it out. It's actually a project whereby you are told to guess a number between 1 and 10. So the number you're going to guess it as an input, then you make sure it's an integer. So you say that if you get it right, then you won. Otherwise, this should have been here. Sorry. That should have been here as well. I think this is now the correct version of the program. I hope now then it's working on your end. I hope now it's working on your end. I hope now it's working on your end. So now you can say that, let me even say, I want to get a random integer. So we've talked about random integer. We're actually getting any random integer number between values that we pass here. So I want to get between 1 and 5 so that we make the game even easier, 1 and 5. That one here. So then it gets our number between 1 and 5. So if you get it right, we won. If you don't get it right, we lost. So if I run now the game, can you guess a number between 1 and 5? I guess 3. I won. So I actually won. I actually guessed 3, and the random number also generated 3, so I won. Okay. So if I try again, I don't think I would win. Now, if I say 2, I lost. So I guess the number 2, the correct generated number was 3. So this is actually foundation of now building even gaming application. Most of the time they work with these built-in functions that are there in our programming language. So if I get one last one like 1, I won. So I actually won second time. And I can now be storing, anytime someone wins, you can store the points in another variable. So you can even advance more on such kind of games. So now someone can try this one and now see where you can actually work with modules. So any questions so far so good up to there? Any other question up to there? So my idea was that at least you understand what is a modules and you are able to work with the module in your programming practices. So at some point, we are going to meet the word import, and I hope it will not confuse you here. Especially tomorrow, you'll now start importing NumPy, because now we start by learning numerical computation in our data classes. So any question up to there? I want to share this notebook on the chat. For anyone who wants to do more practices, I can copy this link and share it here. So that was the first one. So a module, just to recap on it again, a module is basically a file. So the third-party modules that we have here, we'll talk about them tomorrow. When now we'll be installing NumPy, we'll be installing pandas, and so on and so forth. So just to recap on it again, a module in Python is a file containing Python codes that can be reused across multiple programs. So if you have a file with functions that you can use on another separate file. So that demonstration was done here. That is what was done here. I hope you have, like, for example, you have a module with function to get gravity, to print, and so on and so forth. Then this operation, you can use them on another separate file. Basically, that is what we'll be calling modules. So any question up to there? So in the next remaining time, we would want to talk about object-oriented programming. Object-oriented programming. Okay, looks like you're good. So let's now move to the next part, where we'll now discuss object-oriented programming in Python. And this will be very important to prepare us for the next lessons, especially now we'll be introducing data science and data analytics tomorrow. Okay, so let's now move to the next part. So if that is okay, you can now close these two. And now we proceed to OOP in Python. So these are very advanced topic. In most school, it takes like a whole 3 months to understand OOP. So basically, we want to understand it here with Python. And we want also to understand why OOP is also useful in data science and data analytics projects. So I want to give you the 2 remaining minutes. It's already 10:13, Nairobi. So we can now start in the next 2 minutes with OOP. So in the meantime, as usual, make sure you have the notes here. Make sure you have the notes so we can go through the notes together. We understand what is object-oriented programming in Python. And then for class practices, as usual, We now use this class practice here to practice more on OOP. That one. Then definitely we'll have to create a Google Colab. So let's create a Google Colab. We can define a new notebook. Here, we discuss object-oriented programming. So I'm creating a new notebook. I'll close this one. You can call this one object-oriented class practice. And then this is actually for our morning session. So I hope you're ready. So make sure you have the notes to discuss OOP together. I want to just pick the most detailed part, the important parts of OOP. We do the important part of OOP in Python. And then I would highly recommend now we do class practices. So let's do the setup. Let me add you 1 more minute, then we can start together. So make sure you have the notes here. Make sure you have the notes here. You have the guide notebook here. And now we have the practice here. And then you're ready to start. Okay, so I hope you are ready with the setup. So let's start by now discussing object-oriented programming. So we start from here, OOP. In other words, it's called OOP. So you're going to see that object-oriented programming is a paradigm. So this is a style. So it's a programming style where we organize code into objects. Okay. So let me actually repeat that definition. So we can say that object-oriented programming is a programming style where we organize code into objects. Let's start from there. So someone doing OOP basically tries to organize his program using objects rather than functions. So that is what I want you to see. You're using objects rather than function to organize your code. Okay. And now to understand OOP in a better perspective, then we can say that an object contains both data that we'll later be calling them attributes and functions that later we'll be calling methods. Okay, so an object contains data and functions. In other words, an object contains attributes and methods. Okay, so in such a way that we are trying to organize our codes in terms of objects. Okay, so later we're going to see that OOP helps improve code organization, code reusability, and code maintainability by actually modeling real-world entities. So that is actually very important to note. So we are trying to now model real-world entities in terms of objects by defining their attributes and their method. So this is actually how I understand OOP. In other words, we can actually say that object-oriented programming mainly treats everything as an object. So you're being told that anything you see in your environment is an object. So that is what we call object-oriented programming style or paradigm. So basically, we are told that an object, it's anything that contains attributes and method. So for example, if you meet a person, you're walking along the road and you meet a person, This person that you're meeting has his own attributes and its own method. A good example of an attribute is this person has a name, okay? Or this person, there is a certain height that he has. Its attribute could be height, name, color of the skin, tribe. So those are what you call the attributes. Now, the objects are what this person can do. For example, this person can talk, this person can walk, okay? So an object contains attributes and method. Let me even try another example. You go to buy a car. So the car that you're buying, you will check the attributes for this car and check the methods for this car. If I'm talking about the attributes for this car, it's something like mileage, color, brand. So those are the attributes of the car, even the cost. Yeah, if you want to buy Bugatti, the one big factor about it is the cost. So the cost is an attribute. The color, you want the color, you want the model, you want the mileage, you want the speed, and so on and so forth. Now, the methods will refer to now because you have this car. What can you do with it? I can drive it. I can park it somewhere. I can actually hold. So the methods are actually what the car can do. Okay. Let me try one more example. You want to buy a phone. And then let me work with that, a good example for everyone. You want to buy a phone. So the phone that you want to buy, it's an object because that phone has some attributes and some methods. So a good example of an attribute in your phone could be the camera. How many megapixels do you have? The battery, the SIM card, maybe it's a single SIM or a dual SIM, the color, the size, probably, the model, maybe you want to buy an iPhone, you want to buy an Android. Like those are the attributes of the phone that you want. And now based on those attributes, what can you do with this phone? I can take a selfie, I can call, I can buy airtime, and so on and so forth. So basically, in object-oriented programming, in summary, we are trying to model real-world entities as objects. We are trying to model real-world entities as objects by defining that these objects have properties and methods. So let's write that one. I think that one is very important to understand because it's actually the most confusing part in OOP. So we can now say that we are now trying to understand object-oriented programming. So we can say that this is actually a programming paradigm. So I've said that a paradigm is a style. It's actually a programming paradigm where real-world entities, anything you see around you, real-world entities are modeled as objects. So that is what we call OOP. It's a style where you model real-world entities as objects, especially when you want to build a game or when you want to build a mobile app. Then anything you see in that mobile app is an object. The button, the text, the size, the layout is actually an object. Okay. So it's a programming style where real-world entities are modeled as objects. Now we can now proceed further and say that these objects, these model objects that we use to model real-world entities are perceived to have attributes that later We'll be defining them in a variable. We'll be defining them in a variable, so they have some attributes, and they have some methods that later we're going to define them as functions. So the actions they can do. Attributes is what they have. So I can even break it down for you. I just want you to understand it in a more theoretical aspect. So we can now say that an attribute, it refers to what the object possess. What does it have? What do you have as a person? You have your name, you have your age, you have your height. So what do you have? That is what we call an attribute. So what you have is basically stored. It's basically stored in a variable. It's stored in a variable. What do you have? You are an object, because you're saying that any real world entity, it's an object. So even if you're buying a car, the car is an object. If you're seeing a person, the person is an object. If you're in a laptop, the laptop you're using is an object. So what does it possess? So what it possesses is what we call an attribute. And now, the other aspect that is confusing is the methods. So the method refers to, so the method refers, sorry for that one. The method refers to the actions that the object can perform. What can you do now as an object? Why are you a real world entity? What was your purpose here? If you have a laptop, then you can use it for writing a code. You can use it for listening to music. You can use it for playing a video game. So those are the methods you have. What can it perform? What are the actions that object can perform? So these actions can be defined in a function. So they are actions that the object can do. So this is what we call object-oriented programming. It's a programming style where real-world entities are modeled as objects. So these objects are said to have attributes and methods. So an attribute refers to what it possesses, and that attribute, you can store it in a variable. You can say that this phone have a 50 megapixel camera. I want to store that attribute in a variable so that now I can always refer to that attribute. And then with this phone, you can take a selfie. So the action of taking a selfie, I can define it in a function that we later will be calling them methods. Okay? So I was given some good demonstration. I can even say that a person is an object. A person is an object. A person is an object. Why? So the reason is why. Why do you say that a person is an object? Because this person have an attribute and an object. So for example, the reason is that the person has some attributes. So people do have some attributes. For example, any person has a name, you have your age, you have your gender, you have your height, probably, attribute. What I can see, what do you possess? What do you have? You have your name, you have your age, you have your gender, you have your height, and so on and so forth. So those are what we call attributes. So as a developer, or as a software developer, or as a data scientist, I can store these attributes in a variable. Later, we're going to see that one practically. Now, this person, we are saying is an object because it can perform some methods. So some actions, for example, you can walk, You can talk, you can talk, you can eat, because people do eat, and so on. Yeah, but so that is the first scenario. I want to just try to more scenarios so that it makes sense to you what you're trying to model here. So B, I can say that a car is also an object. Number two, a car is also an object. Why is a car an object? A car has some attributes like how much does the car cost? Which color do I prefer? Mileage, the model. For example, I want Subaru, I want Bugatti, I want Toyota. So those are the models, the brand, and so on and so forth. The brand, and so many other options. Now, because this car is an object, it has some properties. Now, what can I do with the car? I can drive it. I can drive it. So there is an action to drive a car. There is an action to park a car. There is an action to, I can even hire it. So those are the methods that I can do to my car, or I can even do an Uber operation. So the methods refers to what can you do to that object, okay? Lastly, like I was even demonstrating, you go to buy a phone. You go to buy a phone. You go to buy a phone. So I can say that a phone is an object. Why? Why is a phone an object? Because a phone has some attributes like, yeah, cost is there. Model is there. Maybe it could be Samsung. You also check camera. You also check battery. You also check aspect like SIM. Is it dual? Is it single SIM card? Then this car, what can I do to it? I can call. I can make a call. I can SMS. I can selfie. What else can I do with the phone? I can join Zoom meetings. So I can use it to join my meeting. So someone already is joining the meeting with the phone. So you can use it for those kind of methods. So let me now go back to my definition. Object-oriented programming is a programming style. Let me copy this one for you. I hope now it makes sense, because the first thing is that OOP has to make sense to you so that now we can demonstrate what we are doing in our programs. So it's a programming style where real-world entities are treated as objects. So anything you see in a real-world entity, a road, a tree, a house, anything is treated as an object. Anything in the real world is treated as an object. It's very advanced, I hope you can see. And now these objects, they must have attributes and they must have some methods. And let me say that an attribute refers to what the object has. What does it possess? What can I say you have? You have your name. Okay, I hope it makes sense. Then what can you do? If I have this car, what can I do with this car? If I have this phone, what can I do with this phone? If I can see a tree on the roadside, what can you do a tree? You can cut it, you can climb it, okay? If you have a cup, you can use it to drink a coffee, you can look at it. So the operation you can do to any real world entity is what we're calling methods. Any question up to that first part? Any question up to there? Now, going back to the notes, if there are no questions, going back to the notes, and let's just go back again here. So we are saying that characteristics of OOP is that OOP have 4 main characteristics. And for this class, I think you're going to do 1, inheritance. So it has characteristic of encapsulation. Don't talk much about that one. Then we also have inheritance. Inheritance, we have abstraction, and we have polymorphism. So what are the key concepts in OOP that you're going to meet? Okay. So the first concept you're going to meet is a class and an object. Okay. Then you're going to talk about attributes and methods. Now in Python, you talk about the self parameter. We'll be talking about structures. We'll be talking about inheritance, method overriding, polymorphism, encapsulation, abstract, and magic methods. Why should we work with OOP? Because OOP will make our codes reusable and modularity will be there. With OOP, we can actually perform data pre-processing and data analysis. We can work with OOP to build web development application. A good example is frameworks like Django and Flask uses the OOP principle to structure how do you work with a web application. Okay. Then OOP is widely used in game development to manage characters, objects, and how they interact with each other. Machine learning, we have libraries like TensorFlow and PyTorch that we later see they use OOP to manage neural network and AI models. Cybersecurity, you're going to see that OOP helps in designing security systems and analyzing network traffic. If you want to build user interface using Python, then there are some libraries like Tkinter and PyQt that are used for structuring the user interface elements. So in summary, we can actually say that OOP will organize our code into classes and objects. These are the four principles of OOP, where we have encapsulation, we have abstraction, we have inheritance, and polymorphism. So I don't talk much about this one because they are somehow a bit confusing for now, but we're going to talk about them later. But you're going to notice that OOP is widely used in web dev, in artificial intelligence, in game development, in data science. So in short, now that you understand Python programming and you want to start building stuff, you want to start innovation, then at some point, you will need some knowledge to do with object-oriented programming. So let's do it practically. We'll then try to understand these concepts that I'm talking about here. Okay. Let's go back here now. Let's go back here. Start. Okay. So this is where we start. We are saying that Python is an object-oriented programming language. Just like C++, just like Java, we have JavaScript, in such a way that everything in Python is an object. So anything real world is an object which contains properties and methods. So the properties are the attributes. Okay. Yeah. So let me show you something just to demonstrate that Python is an OOP language. Okay, I think let me just proceed with some more operations here. I think these notes are not well detailed enough. Yeah. So now you can be asking yourself a question. Where does the class come from? Let's go back here and try to understand where now do we bring in a class? So we can start by saying that this style, everything is an object. So therefore, everything must have attributes and methods. So attribute is what you have. Method is what you can do. So what about a class? So that is a very big question we can ask ourselves. So let's start from, what is a class? What is a class then? What is a class? So let's try to define that one. So we can basically say that a class is a template. So some people call it a template Some other people call it design. You realize some people calling it blueprint of designing, of creating, of an object. Let me just say of an object. I can even give you a good example. I've seen a very beautiful house, and I want to have such house. So for me to start building that house, which is an object, I will need a design first. I will need a blueprint for that house. So that is what we call a class. So inside a class, we can actually say that inside a class, we define, so this is where we define the attributes. So the attributes that we also realize we call it properties. And methods that belongs to a specific object. I just want you to know that if you're able to understand a class, then I think you're done. You've understood OP, you've understood what is an object, and now you're trying to understand then what is a class. So basically, a class is what we use to define or to design these objects as a developer. Now I'm talking about a software developer. Okay, you want to build a game, and inside this game there should be a car, there should be a road. Okay, so these are objects that are in this game. So for you to design them so that now the user can see them, we need a class. So a class will definitely be the blueprint of building an object. Okay, so in other words, so you can actually say in other words, an object is an instance. So that is something you're going to see at some point. An object is an instance of a class. Because we basically are saying that an object should be built from a class. It's actually derived from a class. Okay? It's actually derived from a class. So an object, in other words, it's just an instance of a class. So let me repeat those one. Then if we're able to understand that one, then we're going to write these codes very, very fast because they are somehow very easy to understand. The hardest part is number one, to understand what is OP. Number two, you need to understand what is an attribute. Number three, what is a method? And what is a class? So in other words, OP is a programming style where any real world entity is treated as an object. And therefore, an object is perceived, it's anything that is perceived to have attributes and methods. And now breaking it down, an attribute refers to what belongs to that object. What does it possess? Then method refers to what actions can be done to that object. Okay. Now, for you to start building objects, because you're now working with OOP, you want to start building objects, we need a class. Because now we are saying that a class, it is the design or the template or the blueprint that we can use to create an object. So then finally, we are now saying that an object, it's actually an instance of a class. So basically, for you to get an object, we'll have to derive it, or it has to be built from, this should have off, built of a class. It has to come from a certain class. So any question up to there? So far, so good. Any question up to there? Now let's try to understand what these codes have and see whether now this can even sink deeper into our brains. So let's start from here now. The first thing we saw in programming, so that to prove that Python is an OOP language. Python is an OOP language. How do you define, how do you realize this one? If you say I have a number, as 10, if you print the type of that number, then you're being told that this number, I want us to get that relationship. This number, I'm waiting for that operation to execute. The number that you are dealing with, it's actually from a blueprint of an integer. So therefore, an integer, it's an object. So this is a number. So there is a class called integers. So this object belongs to integers. So this object here, this object that we call number, was designed as an integer. So this is the template. Okay. So what are properties of integer? They should not have decimal. I think that is one that we mentioned. Now let's even try another one. Your name, my name is, sorry, we said, my name is Eric. If I print tab, I don't want to talk about class for now. Just trying to make sure you're trying to understand what you're doing here. If I print this one, this name variable has stored my name Eric. So this Eric, it's an object of a class that was designed as a string. Therefore, the properties of this name is that you should give it some quotation mark. Methods you can do to this object is that you can get the length, you can do concatenation, you can get, you can strip it, and so on and so forth. So we can actually say that definitely Python is an OOP language, whereby everything that you deal with here is definitely an object. Even a variable that you define, it's already an object. You're being told that the number you're dealing with here, it's an object from the class of integers. The name we are dealing with here is an object from the class of string. So therefore, we have some templates that have already designed what we are dealing with here. I hope it makes sense at some point. So therefore, to start creating an object, so I think now that has been defined here. We create a class, we create class to create an object. So a class is like an object constructor. It's what we use to build an object, or a blueprint for creating objects. Yeah. So I think now we can try to do some more operations so that now this one makes sense. So to create a class, we start from there. So let's start with creating a class. Creating a class. Creating a class, okay? We're being told here, please check the notes, we're being told here that to create a class, we need the keyword class, this one here, followed by the name of the class, and then you end it with a colon. So the name should be in camel case. Let me talk about that one here. So there's something to note as you create a class. So as you create a class, this is something you need to remember, is that the name of a class must start. So the name of a class must start with a capital, or let me just say an uppercase. So let's keep that in mind. That is something I wanted you to note as we now create these classes. Yes, as we create these classes, always remember that the name must start with an uppercase, like this one here. I hope you can see. And then there is some camel case in here. So for example, you're walking in the roadside and you meet a person. You meet a person, okay? You meet a person. That is something you meet in your environment, in real world, as a real world entity, you meet people. So the person you meet is a class, is an object. So for you to build this person, you need to define the template. So the template is actually the blueprint of this object. So to do this one, you can actually say that I've met a person and I want to build an object for this person. So therefore, I can create a class and then I call it person. And then I make sure I can end with full colon. And then for now, I don't know what this person has, so I can just pass it for now, pass keyword. So this is actually what we call a class. That is what we call a class. So it's actually how you create a class. So the syntax is very simple. You start with the keyword class, followed by an uppercase name of that class, and then you end it with a full colon. So if you don't know anything yet about this person, you can first pass it. But remember, this NB, so something to remember, so something we'll have to remember is that a class contains properties or attributes and methods that are associated with a certain object. With an object. Okay? So a class contains attributes and methods that are associated with an object, like a person. So inside this class of a person, I will have to design the attributes and the method that I saw in this person or in this object. Okay? So a good example here is that if I want now to build an object, so if I want to build an object, so it's actually creating a class. And now then I go to the next person. Creating an object from a class. So this is what we'll later be calling instantiation. It's the process where you try to create. It's a process where you try to create an object from a class. It's what we'll be calling it later, instantiation. So for example, I have someone like Dennis. Dennis is a person. Dennis is a person. So if I try to print the type of this variable, then I'll be told that this is actually a person. I can have someone else. Just say Dennis here. Yeah, like that one. So if I run this one here, like that one. So I'm being told that this is a person. I can have someone else. Eric. Eric is still a person. Therefore, if I print Eric, then I'm being told that Eric is also a person. I hope you can see that one. Okay. So let's proceed. Let's proceed. I know this is very advanced, but the best way you can try to understand what we are trying to say here is by now trying to write this code. So I want you to say, you met Dennis on the road and you wanted to model Dennis in your program. What you needed to do is to now define how Dennis looks like. So Dennis is a person. So what you start with is the design, the class. This is the template used to build an object. So after designing the template here, then you get that this is actually an object or an instance of the class person. Okay, let's proceed with our notes. I think at some point it should start to make sense. Yeah, like that one. Now, we are being told that in the example above, this one here, these two examples, we have created an object from the person class. However, a class without constructor is not really useful in real application. So with a constructor, we can now define the properties of a class. So that is what that's what you're talking about here. So to define the attributes, define the attributes that we are calling the properties of a class, we need a constructor. We need something called a constructor. So with a constructor, it will now help us to now provide attributes of this person. Okay. So now we can even say further that in Python, we use, now this is now the most confusing part, we can also say we use a function called init function. So with this function, we can now define the properties or the attributes of an object. Okay. Now, even something more confusing we can add here is that the constructor takes the self keyword parameter, let me just say parameter, to add these properties to an object. Now let's try to see whether now at this point it would make sense. Let's try to see whether at this point this will try to make sense. So we are saying that OOP, we are dealing with objects. Objects have properties and methods. So now we are talking about properties. You want to now assign properties or attributes to a certain class. Let's go there now. Let's go there now here. So we're being told that I want to remove this pass and now assign property. So at this point, I'm inside the class. So I'm assigning attributes. So to do this one, just take the notes. We're now saying that we need a function called, so you need to go with the double underscore, 1, 2, init. So you are trying to initialize. You're trying to initialize the attributes. So then this one takes the self argument. You're trying to say that this is a function that we can use to declare attributes of this person. Okay, I think that is what you're seeing here. So for example, this any person can have a name, just like we defined it earlier. So we said a person can have a name. age, gender, and height. So age, gender. Let me just talk about those three. Now, at this point, these names have to be now constructed to the object. We'll have to give them to the object. So to assign these values to the object, we'll have to use the self parameter. So what we are saying that in the object itself, if you want to get the name, then you refer to this name here. I want you to see this one. You assign it the name here. This name here, you assign it here. Okay. What about the age? It's the same. In the object itself, if you want to get their age, then you need the age here. This one here. The one in the constructor. And then finally, if you take the gender, then you want to assign it to this object, you can actually work with the one I've assigned here. Gender. Perfect. Now, I hope at this point, at least something should make sense. Up to this point, something should at least try to make sense. Let's see. First, make sure you run this part. Okay. Up to there now, there is the first person we called Dennis. Can you see? We are now creating someone. So the first person we call is Dennis. Now, this Dennis is a person, so therefore he should have an attribute of a name. This is actually used to assign these values to that class. So we need to provide the name, we need to provide the age, and we need to provide the gender. So to do this one, we can actually do it here, what we are calling instantiation here. So this person, the name is, I don't know the other name. Let me just say it's called Dennis Androge. That is the name for Dennis. So Dennis is an object of a person, comma. Dennis is of age. So that should be a number. Let's say Dennis is of age 23. And then finally, for gender, Dennis is male. Okay. Dennis is a male. So let me remove this one first. So I'm being told that I have an object called Dennis, which is actually coming from a class of a person. So if I want to get the name for Dennis, I can just print here, Dennis dot name. Then if I run this one, I'm getting that the name for this person is Dennis Njoroge. If I want to get the age and the gender, then I'm getting that Dennis is 23 years of age and Dennis is male. So basically, these are the properties of a class persons. I want to share this one with you first. I will share this one with you. So you first design the class. You first design the class. And then from the class, you create an object. So you do what we call instantiation. You create an object from the class. Okay. I can even create another person. Like I have another person like Mercy. So Mercy is also a person. Right one. So we are actually saying that Mercy is the instance of the class person. Okay. So therefore, because of that reason, Mercy should have a name as probably it's called, I'm not sure, Mercy Wairemo. Then Mercy is of age 21. Mercy's gender is She is a female. Okay. So now I can actually go ahead and print. I have an object called Mercy. The name, I'll get it from the constructor. The age, I'll get it from the constructor. The gender, I'll get it from the constructor. So what happens with the self argument? I want you to see this one. What happens with the self argument is that you have assigned this name, Dennis Njoroge. So this variable name has Dennis Njoroge. So this Dennis Njoroge here will be assigned as the self name. So it will be part of that object. Similar age. So this age here will be now assigned here. So this is the variable. This is actually the variable. These are the variable. And then this gender will be assigning it right here. Let's now do more so that now it makes sense. You're still proceeding. So I've added so many other ones. How about methods now? So we said that object-oriented programming, everything is treated as an object. Okay? Everything is treated as an object. So therefore, we can say that an object has properties, which in Python, we are defining them inside the init function. This is what we call attributes. And still objects have methods. So that is what we are talking about here. Where is it? Here. Object. So object can also have methods. And methods are functions which belongs to an object. So these are what the object can do. Okay. For example, in this class, every time you have a person, so now I'm defining an object, so I need to define a function right here. So now we can say that we have a function to get your personal info. We have an object to get personal info. And so that we ensure that this object belongs to a class, that's why it's called a method. A method is a function that belongs to a class. We need to assign it the self argument. So if you don't assign the self argument, it is just a function, it's not a method. So for it to be a method, we'll have to assign it the self argument. Then from here, we can now do any operation here. We can actually say, I want to print your information. So let me print your information here. Let me print your information. Yes, I can work with the formatting string. Then I can say your name is, so here I will format the variable that has stored your name, remember, comma, your age. I will actually format a variable that stored your age. And then finally, your gender, I will format the variable that stored your gender. So we talked about strings having the formatting tags here, like this one here. So we work with this formatting option so that we can now print variables inside these curly braces here, what we call the formatting options in strings. So remember, the name that you assigned here, I want us to get this one clear. The name that was assigned here was stored in this variable here. So this is the variable that stored your name. It is the self keyword that stores your name. Your age, similarly, was stored here. And then finally, your gender stored here. That one. So now with this function, I am able to generate your personal information. So let me run this code and see what happens. So if I run this code, I can even go ahead here and say, I want to take Dennis, which is an object, And then I generate a method. So to get a method, we work with the dot operator. So we say dot, let's get Njoroge's personal info. So if I run this code here, I am getting that the name is Dennis Njoroge, age is 23, the gender is male. Similarly, I think I don't need to do this one. Can we just still have it? Still have it. What about Mercy? So if I want to get Mercy's personal info, I can still call that action. So I can say, Mercy, I get your personal info. So now I'm being told here that Mercy, the name is Mercy Weremo, age is 21, gender is male. So what are we seeing here? Very important, and why we should learn OOP. We are seeing that with just one class. I want to share this one with you. Sorry, should be sharing to everyone. I think Gloria, you have an error. I think I'll check it out. Or alternatively, you can paste your code. Just paste your code on the chat, then I'll revise it. So what I was saying is that we need to learn OOP because we can now make this class reusable. We can use it to now store people's record. I have a record for Dennis, can you see? I have a record for Mercy. I can even proceed. I can store the record for Eric, and store the record for John. So now we are making this piece of code reusable in our program. So let me check Mercy's issue, then we proceed. So now please be asking questions up to there. And now be asking questions up to there. Let me check Gloria's issue. Yes, it's the part, this one here. You're saying this code has an issue. Let me see why. It doesn't have an issue. I cannot get your code. It's the one. Okay. I don't know why my chart. Sorry. Perfect. I have it now. But saying this part as an issue, let me check it out here very fast. I think it's perfectly fine. It should be okay. It's the problem. Make sure you run the class first. Make sure you run the class first. Make sure you run this first. But let me even check what the error is saying. But the code is okay. Let me just check your issue. I can see your code is okay. I don't know what's the issue. Your code is okay. Make sure that you run the class first. If you don't run the class, then this one might give you an error. So for you to get these objects that you're building here with their properties and their methods, then make sure you first need to get the blueprint, the class. This is actually the class. We need this class to build this object. And clearly what you're doing here is what we call object-oriented programming. So if you do any programming language, any OOP language, even if you're doing Java or C++, these are the same concept you'll be learning. You'll be told that this language is an OOP language, so therefore it is built on objects. So we're actually seeing that an object is anything that has properties or attributes and behaviors, okay? And behaviors. So therefore, for you to get this object, you need a class. You need a class. You will need a class that we call the templates of the design that we use to build objects. So from this class, we have objects. So therefore, these objects will inherit the properties and the methods that were designed in the class here. And this is definitely what we call object-oriented programming. It is very, very useful, especially when you're dealing with very complex applications that requires a lot of data. Then you'll actually work with OOP, because I hope you're clearly seeing that from one class, I am able to construct many, many objects. And this object will be stored in my memory. Like this one was stored in this memory, this one was stored in another memory, and all these objects are coming from the same class. Okay, so if you move further, I don't want to proceed up to there. I don't want to talk much about that one. That is actually what I wanted you to see. Basically, that is what I wanted you to see, that Python is an OOP language. Therefore, we can build objects using these classes. So like in the other example I was talking about, car, let's even try car now. Let's try car and see whether we are now, it will even make sense. So let's design a car. Let's design a car. Then you can try the phone. And now we can call it a class. Tomorrow we start on data science. So let's design a car. So let's design a car here as an object, because Python that you're using is object-oriented language. So to build this car, I will have to say that I have a class of a car. And please remember, the name of the class must always start with capital. It should start with an uppercase letter, like car here. And then this car, it has some properties. Like for me to design the properties, so these are what I was calling, the attributes. Or these are what I was calling properties. So it must have some properties, okay? I don't want to, let me just remove mileage. I don't need mileage. I don't even need brand. I just want to have 3. Yes, I don't want mileage. And I don't want brand. Like that one, yes, I have model, I have color, and I have the cost. So this is a car. So this car is an object. So because this car is an object, what can you do with this car? I can use it. I can generate the information of my car. So I can get the model for my car. I can get the color for my car. I can, okay. So what else can you do with the car? What else can you do with the car? I can accelerate it. So a car can accelerate. So this is a method that can be associated with the car. I can break it. So I hope you can see that these are what cars do. Let's say you want to build an automatic car. These are what cars do. So these are methods that you can associate with a certain object. So this is what we call a class. Now from this class, we now start building objects based on cars. So we can have Toyota as a car, we can have Subaru, we can have Mitsubishi, you can have Mazda, and so on and so forth. So let's now build the cars. So now we are now creating car objects from the class car. So this is what we'll be later calling instantiation. So instantiation is the process of creating objects from a class. So I would wish to share this one with you. In case the other one didn't work, maybe you can try this one. And you're going to notice that the more you practice this one, the more now you understand it. You cannot understand it most of the time at first hand. But now, if you now do more practice, then definitely you're going to understand what you're talking about here. So let's try my first car. I have a car called Toyota. My car is Toyota. This Toyota, it is definitely an object that was designed from a class of a car. Let's see, so I have Toyota. So I'll start with the model. So the model for my car, Toyota car is TX. What else? The color for this car I'm driving is, I cannot say it's white. Then the costs is, I don't know, let me just say 2 million. I cannot put some price. So that is my car. So if I want to generate my car information, I can just say Toyota dot car info. First, maybe you want to see the car information. There's a button that when you click, you get the car info. So you're told that the car info is TX, the color is white, the cost is 2 million. Then from there, I can now say, I want to take my Toyota car and I want to start accelerating the car. So if you're accelerating the car, you're going to see that the car will start moving. So the TX is accelerating. So the function that is associated with moving this car will be designed here. And if I want to stop it, I can just say my Toyota car, I want to break it. And this is actually OOP, it's breaking here. So you can also have another model. Let's say now I'm also have another car like Mazda. So I have Mazda is still a car. This Mazda that I'm driving is RX-7. The color is probably black. The cost, I bought it for 1.5. So if I get the information, if I accelerate it, if I break it, you still get that it's still the car that we're getting here. I hope now it start to make sense. And then finally, now I can build one. I think because of time, we can just stop there for today. But basically today we've learned a very important and one of the most confusing concepts in programming. Normally it is perceived as very advanced, but basically if you want to understand OOP, in summary, we can say that OOP is a programming style where anything in real world are modeled as objects. That is where you start. And then we say that this object must have attributes and functions, methods. So we are saying that attributes is what they have, then methods is what they can do. Okay? For example, if you have a person can have these attributes, and these are what people can do. So this is what, if you have this object in your application, let's say you're building a game and you want to design an object of a person, then definitely you'll have to start with a class. Let's say you're building a game like Call of Duty. So you have different personas in that game. So each person have their own properties, okay? So those people, we have designed them as in actually a class in such a way that we have their name, their age, their gender, so we can add more properties to these people, okay? So to ensure that these properties are being added to the class, we'll always call the self argument. So this self argument will ensure that if you provide the name here like Dennis Njoroge, this name will be assigned to the class. Similarly, age, we provide it here, it will be assigned, and so on and so forth. And these are what we call the attributes or the properties of this object. So anytime you call the object, you'll have to assign the properties, and then you can now start calling them methods, because an object must have the properties and an object must have a method. So for example, if I have a person like Dennis, Dennis is an object that was built from the class of a person. So you can have the properties and we can have the methods. Similarly, if you build a car, you can have a car with these properties, and these are the properties and these are the methods. So now then you can now assign properties and methods to every object that you have. So basically that is OOP. The main point here is at least you have an idea about what is object-oriented programming. So much of it all, we are going to meet them. So I want to try this one. I want to try now this one in case others are getting some issues. You can try this one. So probably I've seen that you need to provide these arguments here. So make sure you provide the arguments here. I think I've seen the issue. Make sure you add this argument here. Make sure you have the constructor and you have the methods here. Make sure you assign it the constructor here, and then you assign it the methods here. So basically that was our Python programming. At least we can say by now you have a rough idea what is Python programming. So later tomorrow, we will now be transitioning from Python programming to data science. For those people who are doing data science, we'll be calling it data science with Python. For those people who are doing data analytics, we'll be calling it data analytics with Python. It's not a must that you have all the knowledge. Let me go back to the outline we had. Not here. It's not that a must that you understood everything, because the time we had was also very short, but at least we have an idea of what is Python programming. At least you're able to work with a variable, you know what is a data type, you know what are conditional statements, how do you work with looping, we talked about functions and modules. Now we've talked about OOP. I think the other ones, we are going to add them as we do now our data science project. So the main idea for this course that we labeled Python for data science and data analytics was to give you an overview of what is Python. Maybe this was your first time learning programming. We've talked about some very important concepts like variables, data types, condition, looping, functions. We've even done at least one more advanced module like modules and even OOP. Okay. So from there, now tomorrow, I hope now you join us again, because now we will be transitioning from Python for data science, which make sure you complete all the quizzes maybe by today, so that now tomorrow you are ready, or you are able to enroll to the other program for data science and data analytics. For those who are interested to now advance on their knowledge in Python, from here you can now try and do what we call data structures and algorithms in Python, okay? So there are these platforms that we call LeetCode. So there are platforms that can even help you do these practices. The best one that we have so far is LeetCode. And what you will notice with LeetCode is that it normally helps a lot of people improve their programming skills. I cannot say that because you've done programming for like 3 weeks, you are now an expert. No, the best way now you can transition to an expert is now by practicing. The more you practice, the better now you master this language. So there is a platform called LeetCode out there. It's for free. You can always find time to do their challenges. Like you can even say after every 3 days, I do a LeetCode challenge. And basically, later you're going to realize that this is how you're going to master well this language. But for our data science and data analytics project, I'm very, very confident that now, based on the outline we have here, especially up to here, for now, we are now able to now start data science or data analytics using Python. So I hope by at least tomorrow you're able to understand variable, data types, condition, looping, and functions. That is the first important part. Then later, as we'll be doing more complex stuff, like artificial neural network, we'll be doing computer vision, we'll be talking about generative AI. Then you realize that we'll have to add more advanced topics like OOP, we'll be talking about exception handling, we'll be doing some file operation later. So that one marks the end of this program for Python. So let's meet tomorrow. We introduce data science and data analytics using Python programming. So up to there, you can ask any question so far if you have any. So make sure you sign into this platform. It's good. And then you are going to realize how good you'll be in no time. So any other question up to there? Okay, so I can see there's no question. I wish to stop there for today. So thank you for the consistency. Now let's proceed in the same consistency on the next area where we'll be now starting data science with Python or data analytics with Python. Yes, Gloria, you have a question, you can go ahead. You're still getting the same error. Okay. Okay, so what we can do, could you share your screen? Are you able to share your screen? Are you able to share your screen? So now we are winding up. Perfect. Let me stop sharing mine. You could share your screen. Then we'll have a look at it. Share screen. So up to there, I can now call it a day. Share screen. Okay, so I think because we are recording the same session, probably maybe you can have me on inbox. So have me on inbox, and then we can. So then we can rectify that one. So that one, let's have a nice day, and then we meet tomorrow for data science.